CISP453. So we used to have that class, but because of low enrollment in that class, we have not really offered it, since maybe 2 years ago. So if you want that class to be offered again, you have to talk to Damon Antos. He is our department chair, but he is responsible to decide, what classes to offer. Because the FTE, we are only allocated so many FTEs or full-time equivalent to the entire department. So we have to offer these CISA application classes, the core classes, programming classes, networking classes, web classes, and security classes from the same pool. So they have to do a balancing act, as to how many units to allocate to just programming classes, and how many units to allocate to the other types of classes.
Because if you plan on going for a bachelor's degree,
right,
you have to take a unit first class.
Right. You can take that class, over, at the CSU, but as far as I know, they also have problems filling that class, at CSUs. So it's a tricky situation. I would like to teach that class. It's a really fun class to teach because in that class, I teach socket programming, where you can write a server program, where other programs, a client program, can connect to it, and then you can do just kind of fun stuff. And then it starts with a single client and a single server. Then you have multiple clients to a single server, and then you start with only handling one connection at a time. Then you can handle multiple connections at a time without using multi-threading. So there's a special kind of system call in Unix or just any modern operating system that allows you to do that. So it was a fun class, but we have not been offering that class for a long time. So anyone who wants to transfer to a CSU and just want to get CISP453 resurrected, you can send an email or just talk to Damon Antos. He's our department chair, and basically say that there is a demand for that class and you guys need that to transfer to a CSU. So if there are enough people, I think he will reconsider and reoffer that class. The problem with that class is it's only transferable to a CSU, but it's not transferable to a UC. UC doesn't really need that class. And that's why the enrollment of that class usually tends to be low compared to the other classes. Like CISP310, the assembly programming class, is required for both CSU and UC, so that class has no problem filling up. But 453 is only for CSU classes, transfers, and that's why we have problems filling in that class.
Well, the problem is if you don't have that lower division completed, you can't apply directly to the computer science program. You have to go in as a pre-computer science student and then apply with everybody else once you get to the CSU.
You can still get most of your classes articulated and transferred, and they will count your classes. But yes, you have to go through some extra steps to get it done.
Right, because you have to have all your lower division completed before you can be accepted as a full-time computer science major.
You know what? This is something that's good to bring up to Damon Antos, because he may not understand that part, from your perspective.
Yeah.
So I would, just get an appointment and talk to him directly, and basically explain to him, without that class, it's a lot harder, or you have to go through more steps, to get transferred to a CSU. Because I don't think he understands that part. He only understands that the enrollment is low, and that's why we are not, offering that class. All right. So are there any questions about your homework assignment? Has anyone given it, any thoughts? No. I can actually tell, how many people have even looked at the homework assignment,
I'm going to say 6.
Well, Moodle is great, for stuff like that. I can go to reports, and I can go to the course, maybe activity report. There are, so it can show, this is fine because it's not telling me, who has, clicked, what, how many times. It's just, showing, what do you call this, the statistics. So it doesn't, really single out a single particular person. So when you look at binary search tree, which is the homework assignment, there are 28 clicks on it. And I think this class is about 30 people, So I'm pretty sure some people have not clicked it yet. You know.
I haven't yet done.
So you might want to get started with this one, as early as possible, because we only have next Tuesday left. That is our last lecture. Okay, the exam is 1 week after that, but as far as lectures are concerned, this is the second last, and the next Tuesday we have the last lecture, which is the last opportunity really to talk about homework assignments and anything related to the homework assignments. So you got to be get started early, and then if you have questions, we have a chance to talk about it.
Did you fix that homework assignment for your 310 class? Remember?
Oh yeah, that one is that's funny.
Wait, so I have a question actually. Since you're on
Yeah, go ahead.
So remember how you moved that question? When you moved it into the other question, you just basically duplicated it. So now there's two of those, and one of them just not.
Yeah, I would just go ahead and remove that item. So that's not a big issue. Yep.
The exams next week or the following week?
It's according to the final exam schedule, which I cannot remember.
May 16th.
Yeah, it's a weekend.
10:15 to 12:15. May 16th.
It's on May 16th?
Yeah.
It's a week from today.
A week from today.
Yep.
May 16th.
May 16th, so next Thursday.
Really?
Because it seems very confusing.
That's earlier than I thought.
That's because finals week starts midweek.
I did it last spring too. I don't understand why.
Okay, let's double check, because I don't want to. Okay, you're right. This class is a Tuesday, Thursday class, and it is May 16th, 1 week from today.
That's because technically Wednesday is the last day for all classes, and so there are no classes that are offered on just Thursday, Friday. It's either Monday, Tuesday, or Wednesday. So the last class meeting is facilitated by making the semester always end on a Wednesday.
Okay.
Yeah. So then the finals start the day after.
Yeah, but the homework assignment is going to be helpful to prepare you for the final exam. I think last time we talked about pre and post conditions, but besides pre and post conditions, it will be basically everything that we talked about, including subroutine invocations. That's the one thing that we have not tested in the exam 2. So you can count on the final exam to be kind of heavy on subroutine invocations, parameters, passing by reference, passing by value, and also records. So those are the new things that we have introduced since exam number 2. So are there any questions in general about the newer topics, the topics that we have introduced since exam 2? No particular question? Yep, go ahead.
Can we go over some of the examples, some examples?
Absolutely. So let's go take a look at.
Is the recorder on?
The recorder should be on. Let me double check. Yep, it is. It's recording, and I think it's capturing. Okay, so it's definitely up and running. All right. So let's go back to Moodle, and if you scroll all the way down, we have final exam, practice final exams, and then more final practice exams. So there are 3 at least, that are already up there, and then there's one that is specific to pre and post conditions. So let's go ahead and click on the first one. It's called FX for final exam, not special effects. All right, so here it is. This is one of the older ones. When I actually had the final exam, conducted in the lab, as an online exam. So we'll go ahead and take a look at this one first. I remember this one, very vividly, because this exam was scheduled in the lab. And I was using, LibreOffice, and LibreOffice was installed, at the lab. So I thought, okay, everybody should be able to open it, and since we use LibreOffice in this class, so there should not be any problems. Except, on that particular day, the network access in the lab in room 152 was broken. So we found an alternative, because the room next door to this one, room 122 and 123, that's our Biz Tech lab, and they have computers, and they did not have people using those computers on that day. So we just said, well, it's okay. We just have to move to a different room, and then we can still have our exam online. Except those computers did not have LibreOffice installed. At the time, it was still OpenOffice. And I thought, well, that should not be a big problem because Microsoft Office can actually open OpenOffice and LibreOffice documents, but only after you update Microsoft Office 2007. And guess what? Those computers have not been updated. So they could not, my students could not open up these documents for the final exam. So I had to convert everything to Microsoft Excel format, like on the fly, so that my students can actually answer the questions. Fun day. So there is something to say about putting the questions on a piece of paper, because it's really hard for technology to fail on a piece of paper. You can always borrow a pencil or pen from somebody else, if that fails. Yep.
We are having an exam in lab 152.
I'm inclining to do it on paper, just so that just because we have been doing it on paper for so long, because if I do it online, there'll be other things online, in the Moodle exam, setting that you have not seen before, and that's why it may introduce some elements that we are not prepared for at that time. So I'm going to do it on paper, just like with the other exams. I heard that.
To make sure the grid printed. Yeah.
Oh, the grids. Yep. I have to buy additional toner.
Yeah.
All right. So this is an algorithm in one of the tests. It's a recursive subroutine. We have arrays involved here. We have parameter A is passed by reference. It's an array of integers. We have parameter I, which is passed by value. You can see that it's a recursive subroutine because in Evo it is calling itself. Okay, and in this particular exam, people have to trace it to figure out what the algorithm is supposed to do. And if I remember correctly, sheet 2 starts with a particular value, and I think X, Y, Z are supposed to be like the first 3 digits of a student ID, or something like that. So let's go ahead and get started with this one. Go back to sheet 1, look at the algorithm, and then open a new window to look at the trace. And I'll just go ahead and change these to 5, 2, and 7. Okay. Doesn't really matter. Okay. So now we have the precondition. B is the only global variable in this case because B is involved on line 10, which is outside of the definition of a subroutine. So any variable that is used here outside of the definition of a subroutine, they all have to be global variables. So B is a global variable. Right? So execution starts on line 10. And on line 10, we are invoking Evo. And we have to decide whether to use return line number or return info. And which one should we use in this case? How do we decide? You'd have to study the subroutine itself to decide. Yep.
Return info.
Return info because there's a return statement. Okay, because there's a return statement in the subroutine that we are invoking. So in this case, we need a return info. Okay, so with a return info, what do I write in column F? In other words, did I just write down 10 as the line number or post as a line number?
Yeah.
Or if not, what do I do?
Line
Okay,
10 and whatever.
we say line 10, okay, because we have unfinished business on line 10. But on top of that, we also have to basically we have to copy everything on line 10 other than the invocation itself. Okay. Now, when I look at the previous homework assignment, I saw a lot of people, did not exactly follow that, convention. So in this case, the print is not done yet. So you have to include, print in it. The invocation of Evo is the only part that is replaced by a single question mark, because that's what we are doing in this particular invocation. Okay? It is important to remember to include this part here. Whatever is not the invocation, you have to include it so that we remember when the invocation of evil is done, when we come back to line 10, what else are we going to do? How do we continue the execution of line 10? That's the whole purpose of the return info column, is to tell us, okay, we're going back to line 10, but what else are we doing when we get back to line 10? Okay, so you got to understand the rationale of why we are writing down this particular information in column F. Now, when you're invoking a subroutine, you also have to allocate for all of the parameters as well as all of the local variables. We don't have any local variables in this case, but we do have two parameters. So we have parameter A and also parameter I. Parameter I is the easy one because it is passed by value. It is bar B bar minus 1. Let me just put a pointer over here. In other words, we have to calculate the number of elements in B, subtract 1 from it, and whatever the value is, we will use it to initialize parameter I. B has 3 elements. It has elements C, D. Well, the elements are in columns C, D, and E, so there are 3 elements. So bar B bar itself is 3. 3 minus 1 is 2. So we are actually initializing I with 2. A, on the other hand, is passed by reference. If it is passed by reference, you cannot, it's no longer, it doesn't have a value by itself. Instead, it is a reference or an alias of something else. In other words, every time you have passed by reference, in the column for that particular parameter, it is also known as, to indicate it is an alias of something else. In this case, it is also known as columns. Which columns is parameter A an alias of? C, column C to column E, okay, because it is an entire array, so it is an alias of multiple columns. All right, so this is how we set up, the columns that we need for this particular invocation. Then we can continue execution in the subroutine itself. Now, this is another thing that I have to re-emphasize, is when you invoke a subroutine, it doesn't matter whether you're invoking from outside the subroutine or it is recursive and you're invoking from inside the subroutine. But every time you invoke a subroutine, you always start from the beginning of the entire subroutine. In this case, we are invoking from outside, so it's kind of clear that we have to start on line 4. And line 4 is a conditional statement. It starts with, I is different from 0. Well, I has a value of 2, so I is different from 0 is definitely true. Then we move on to line 5. Now here is where things can get a little bit confusing, because line 5 has both an invocation of a subroutine as well as a return statement. Okay? So what you need to do is to think, okay, but what can I possibly do at this point? Can you do a return at this point? Do you know what value you're supposed to return? No. So forget about it, okay? So you're not returning. Can you even do the addition or the multiplication? No. Okay, so forget about those. The only thing you can do at this point is to invoke, evil and find out what that invocation will give you as a value. Okay? So your job on line 5 at this point, right now at this point, is to invoke evil again. So you have to use return info. Okay, now this time you have to be careful again, when you specify the return info. In other words, when you're coming back from invoke info on line 5, what else am I going to do at that point? That really is the question, because that will determine what you need to write as the return info for that on line 5, when line 5 executes at this point. So you have to say, okay, I'm going back to line 5. I'm not done with the return yet. I'm not done with the addition yet. I'm not even done with the multiplication. The only thing I will be done with is to resolve the value of the invocation. And that's why that is the only part that is replaced by a single question mark, is invoke evil, A specifies A, and I minus 1 specifies I. Yep.
You can't do the addition yet at all. You can't do.
You cannot do the addition because you can't even do the multiplication. Right?
Yeah.
The order of the operation is, if there are no additional parentheses, you have to do the multiplication first.
Can you specify a value for A?
For A bracket I?
Yeah.
Now that part gets tricky, okay? It gets tricky because what if the invocation of evil is going to change the element's own value?
Right, but it wouldn't change it until it got back to that return, like, because you're gonna return again, because A bracket I is not gonna equal 0 again. So that value will already be whatever its current value is.
No,
there.
not necessarily. That part is dependent on the implementation of the compiler. Because I'm not accessing I, I'm accessing A bracket I as the first thing of the addition.
Right.
And that can change. That can be changed by the invocation of evil. Right? So as a result, whether you can actually take a snapshot of A bracket I at this point and change it into a literal value, I would not do that because at this point that can still be changed. Now looking at this from the perspective of a compiler, most compilers will do the invocation first before they go back and evaluate the rest of it. Is that making any sense? Yep, go ahead.
Is there a way to force the compiler to to evaluate the invocation first?
Yes, the only way to force a compiler to do that is to separate invoke evil from the return statement and from the rest of the expression. So you basically have you will need a local variable in that case. So let's say we have a local variable x in this subroutine. So right before line 5, we have x gets invoke evil blah 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 blah, and then on line 5, instead of the invocation here, you just replace it with the local variable x. So that way it becomes extremely clear the order of operation, because you have to perform the statement before line 5 and then line 5. So in that case, you know that you're invoking the subroutine first and then evaluate the multiplication and then the addition. But in this case, because it's on the same line, it is entirely up to the compiler to decide the order of evaluation. So one compiler can say, oh, you know what, at this point, since I know what A is and I know what I is, I'm going to evaluate A bracket I and come back with a particular value before I even go invoke evil. Okay, that's entirely possible, but that's risky because evil in this case it does not, but it can potentially change the values of the array that you're accessing as the earlier part of the expression. So, but as a general rule in this class, we do not evaluate the rest of the expression until the invocation is done. Are there any questions about that? That's a good question, but it does open up somewhat of a can of worms. Okay. So once we're done with the return info, which specifies what do we have to do when we come back from this invocation, then we can specify the rest of the parameters. Once again, we have parameter A and parameter I. Parameter A, according to line 5, is really just A itself. In other words, I'm passing a parameter that is passed by reference to me and pass it by reference again to another subroutine. In that case, all you're going to do is to pass the reference along, and you're not going to pass a reference to a reference. So in this class, and not even in C and C++ or any known programming language, you don't pass a reference to a reference. You just pass the reference itself along. So in this case, A is just also known as it is an alias of column C to column E. I is the only one that gets changed because I'm using I minus 1 to specify I. The I in the I minus 1 refers to the I that is already known, which is column H. Column H has a value of 2. 2 minus 1 is 1. So that's why this new I has a value of 1. Are there any questions about how the columns are set up for the second invocation of evil? No questions? This is all good? As I said, a few times in this class, going forward is actually the easier part. It's when you're returning, then things can get a little bit confusing, especially when we have a return statement, in the return info cell. Because in that case, we're saying, okay, but what are we returning? Are we dealing with the return statement in the program, or are we dealing with the return statement in the return info cell? So that's the part that can be a little bit confusing. Once we set up all the columns, we can now continue execution. And where am I supposed to go? I'm invoking eval, but this time I'm invoking it from inside eval on line 5. So where do I go next? Line 4, okay? Because every time you invoke a subroutine, you always start from the very beginning of the entire subroutine. Okay, so that's a very, very important part to remember, is we always start from the beginning. So this time I has a value of 1. 1 is different from 0 is true, so now we go back to line 5 again. And basically we're doing it one more time. If I update the, just kind of scroll the screen, I'll break it up into 2 different parts. We're basically doing exactly the same thing. We're invoking eval again. And this time, the only part that gets changed would be the value of I, because it goes from 1 down to 0 in this case, in this particular invocation. But the rest of it is still pretty much the same. So now we get back onto line 4, because this is the 3rd invocation of eval. But every time we invoke, it doesn't matter whether it's the 1st, 2nd, or 3rd time, we always start from the beginning of the entire subroutine. And this time I is different from 0. I is different from 0 is false, because I is 0 itself. So because line 4 has a condition that is false, we have to go to the else case. In other words, we go to line 7. And line 7 has a return statement. It returns a bracket I. So let's go ahead and slow down a little bit here and see what we do when we execute a return statement. Okay, so when you execute a return statement, there are 2 things to do procedurally speaking in this class. One is to copy and paste the return info cell. Second is to replace the question mark itself, and only the question mark, with the value that you're returning. And you don't touch the rest of the return info cell. Okay? So in this case, let's perform those steps here. First step, copy and paste the return info cell, just like that. Second, figure out what value you're going to return on line 7. Line 7 says return a bracket I. A is an alias of column C to column E, which is an array, and I has a value of 0. So we are returning a bracket 0, but since A is an alias of B, so we are effectively returning the value of B bracket 0. We look up column C, it has a value of 5, so we are returning a value of 5. That's why in the second step of this return statement, you change the question mark to 5. But you don't touch anywhere, where you don't touch anywhere else in the return info cell. So we go here, we look at the question mark here, we change it to a 5, and we are done with this return statement. The fact that it is also a return statement inside the return info cell doesn't matter at all. Okay? That is the part that you have to remember, is it doesn't matter whether the statement in the return info cell itself is a return statement. We are not going to deal with it. Okay, this is not the time to execute it, and all we want to do is to replace the question mark. That's all. Do we have any questions at this point? Questions? All right. So after line 7, we get out of the conditional statement. We end up on line 9, which is the end of the entire subroutine. At the end of the return, at the end of the entire subroutine, we have 2 things to do again. One is to figure out what are we doing next, because this is the end of a subroutine. We have to go back to somewhere to continue execution. That information comes from the return info cell in this case. So we are going back to line 5, but line 5 is going to look like this when we get back there. In this class, or in this particular reincarnation of this class, we have an option. You can actually copy and paste column, this particular return info cell over here. So it becomes extremely clear, what we're going to do when we get back onto line 5. Or, in the notes, I just say, return to line 5 and then refer back to L13 in this case to tell us, what we have to do when we get back onto line 5. So that's the first thing you have to do at the end of a subroutine. The second thing you have to do at the end of the subroutine is to deallocate all the columns that were allocated for this particular invocation. So in our convention is just to use strike through to indicate these columns are no longer in use, and now we are back to line 5. Okay, let me scroll the other portion so we can reestablish the current context. So now the active columns become I, J, and K, because from column L and up, those are now deallocated. So now that we get back onto line 5, and line 5 says, I want to return the value of A bracket I plus 3 times 5, do we have any additional invocations at this point? No additional invocations. Very good. So it seems like we can actually go ahead and evaluate the entire expression. In this class, we use the typical priority of operators like in math or physics or any type of scientific classes. So we perform multiplication first and then the addition. Okay. 3 times 5 is 15. I currently has a value of 1. A is an alias of B. So we are adding B bracket 1 to 15. B bracket 1 has a value of 2. 2 plus 15 is 17. So we are effectively returning a value of 17. So now we execute the actual return statement. When you execute the return statement, once again, 2 things to do. Copy and paste the return info cell. Change the question mark to the value that we are returning, which is 17. And that's it. Okay, we don't do anything else. We're just going to change the question mark. Yep.
So we don't need to show the process of doing, 3 times 5 and the reference. Okay, so you can just throw it in.
Yep.
All right.
Yep. In other words, the evaluation of A bracket I plus 3 times 5, we don't have to show that.
Yeah, I wasn't sure when we had the homework on this, so I think I put another line in there or something.
If you put it in the comments, that'll be fine.
Okay.
If you want to remind yourself, okay, this is the actual value that we are returning, and that will be fine with it.
All right.
You can always add things that I typically don't track, in the comments column if it's helping you. It's just that the removal of the minimum of what I'm expecting, that would be a problem. Okay. So are we still doing okay so far with row 15 of the trace? Is that okay? Okay. So after this, which is line 5, so this time we can actually proceed because I just executed the statement on line 5. We can now proceed to line 9, which is the end of the subroutine, because we are done with the conditional statement, and there's nothing else after the conditional statement. On line 9, we have 2 things to do. Once again, we have to look at the return info cell and then say, oh, since this particular invocation is done, this is where we're going back to. We're going back to line 5, but we'll execute line 5 later on. And then the second thing you have to do is, once again, deallocate all the columns that you allocated for this invocation. And now we can continue execution on line 5. Columns I, J, and K are now deallocated. Our context is now columns F, G, and H. This is my new line 5 to execute. It has, it's return A bracket I plus 3 times 17. There are no more invocations involved here. I can actually do this I can evaluate this particular expression. 3 times 17 is 51. And A bracket I, A refers to B. A is an alias of B. I at this point has a value of 2. So A bracket I is B bracket I, which is B bracket 2. It has a value of 7. 7 plus 51 is 58. So we are returning a value of 58. When we return 58, we do exactly the same thing as we always do. We copy and paste the return info cell, just like that, and then change just the question mark to the value that we are returning. In this case, it is 58. And we are done. I'm done executing line 5, the return statement. After line 5 executes, once again, we get out of the conditional statement, and then we continue on to line 9, which is the end of the subroutine. Line 9 has 2 things to do. One is to figure out what am I supposed to do after the subroutine. We're going back to line 10 and print 58. The second thing it does is to deallocate the columns, in this case F, G, and H. we are now done with line 9. We now continue execution on to line 10. Line 10 is really just print 58. There are no more invocations involved, so I'll just go ahead and print the value of 58 to the screen, to the printer, whatever output device is connected to. And after that, we are all done. So we have post, and that's the entire trace of the algorithm. Are there any questions about this algorithm or the trace of it? Yep, go ahead.
Why does the entire trace spill out into column J, as far as column J?
Why does the
Entire trace spill out into column J?
It's actually beyond column J. It's actually 3 columns beyond J. If I take this out, there are 3 invocations of the subroutine, and each invocation of the subroutine will take up 3 columns, and that's what the entire thing looks like. Essentially, every invocation, you have to allocate columns for each invocation. 1 to the return line number or the return info, 1 to each local variable. Well, okay, I shouldn't say 1 because it depends on the type of the variable and also the parameter. But you have to allocate, on the fly, every single by-ref parameter, every by-val parameter, and every local variable will need at least 1 column depending on its type. Okay. So the key point, is the allocation is on a per invocation basis, not on a per subroutine basis. You can have 1 single subroutine, but if it is, if it's recursive, you can still end up using a ton of columns. But if the subroutine is not invoked at all, it doesn't use up any columns. Yep.
So the allocation of by value variables E and A, those sort of pertain to our homework on binary search tree homework.
The binary search tree homework is a little bit more complex because the array is not an array of integers.
Right.
It is an array of nodes, and each node has 3 members. But the concept still applies just like this.
We only have to reference it. We don't have to use a by value reference. We have to give us an array B,
And it's passed by reference.
and then it's by reference. We don't have to make it.
Well, in C and C++, the only way you can pass an array to a subroutine is pass it by reference. It does not have the ability to pass an array by value. In some other programming languages, you do have the ability to pass an array or list by value. But in C and C++, the only way you can pass an array is to pass it by reference.
The new local, that's what I was saying, the new local variable A, which is by reference to B, array B, we only need to set it up like that.
It'll be a very similar kind of thing because it's an alias to some other columns. Right. All right. So if there are no questions about this, we move on to the next question of this particular practice exam. Now, when I say it's a practice exam, it's an actual exam in 1 year, in 1 semester that I taught this class. So this is actually a question. So you can expect something kind of the same complexity in your exam. So let me make a folder for today, just in case we want to save it, post it online. So 0509. Here. All right, so that's done. Moving on to the second question. Okay, second question is MR2. Not Mr. 2, it is MR2. Does anyone know what MR2 stands for? It's a Toyota car. So what does it stand for? Mid-engine, runabout, 2-seater.
There we go.
Most people think it's rear-wheel drive, but it's not. It's actually runabout. It's supposed to be a little car that you can drive around for errands and whatnot. It's not rear-wheel drive, but it is rear-wheel drive and rear engine. So it's kind of an interesting car. If I could find one in good shape, I would have bought one.
My buddy had a really nice one.
A first gen?
Yeah, but he ended
Oh.
up selling it.
Hmm?
He ended up selling it without me knowing. Found out like 2 weeks after he sold it.
Oh.
Killed me inside.
Those cars are difficult to maintain because of the position of the engine, but
There's
just
no room.
Yep. Okay, so this is the second algorithm. It is also recursive because you can see MR2 calls MR2 or invokes MR2, but this time the return value is not an integer. It's returning a Boolean value. The rest of it is pretty much the same, kind of like the other ones. Well, instead of tracing it, I would just kind of see whether you guys can figure out what it does. Okay, what do you think subroutine MR2 is actually doing? But let's take a look at the at the code. We'll just kind of analyze the code, in a way to kind of without tracing it, try to figure out what it does. Okay, so the first line is if I is less than bar a bar, then go ahead and do this. Otherwise, it will return false. Okay, that doesn't tell us a whole lot. But when you look at the return statement, it becomes a little bit more clear, what it might be actually doing. It's doing this one thing here, where a bracket I equals k is a part of a disjunction, and it's the first part of the disjunction. So that means if k, which is passed to me as a parameter by value, if it matches one of the elements in the array, I can return right away because I don't have to evaluate, because of the short circuited evaluation, I don't have to do any invocation. And that gets back to the previous invocation, and it gets back to the previous invocation, but because it's a disjunction on line 6, so if one of the invocations down the line returns true, then the true will propagate through the earlier invocations, and basically the end result is just true. So what do you think this is actually doing? We have seen this algorithm already, but not in its recursive form. We have seen it in its iterative form. It's searching for a value. It's actually searching for the value k in array A.
It's a recursive search.
It's a recursive search, exactly. Okay. So that's basically what it does. To trace this is about the same as the other one. It's just that this one has a little bit more. It takes up more columns because we have one additional parameter in this particular one. So do you guys want me to trace it, or do you think it's about the same as the other
It's not
one?
binary,
It's returning a binary value.
but I'm saying it's a linear search.
It's a linear search.
Recursive linear search.
Yep, it's recursive linear search. Yep. You guys want to do it, or kind of move on to a different question? You want to do it? Okay, let's go ahead and do it. This one kind of illustrates how you can combine different things that we talked about in the class and still have the whole thing make sense. Okay, so we'll go ahead and trace this one. I think sheet 2 is set up pretty much the same way as the other one, which means it has specific values already specified here, and so we'll go ahead and resize this one. All right.
Maybe to make that first one smaller. Maybe to make that one smaller.
Yeah. But this line, well, okay, this is what I can do. I can do a format cell. Yeah, we can wrap text. And when I do something like this, it would just kind of not wrapping.
Well, you probably have to resize it. Yeah.
Now it's wrapping. Because of the width, it's just rolling off the cell. It is wrapping. It's just that we can only see the first row, of the wrapping. But now it's wrapping correctly.
It doesn't just auto size?
Nope, it does not. It doesn't do the auto size. So you can still control the sizing if you want to. Okay. So this way we get a little bit more room in the other view of the same spreadsheet document. So that's nice. All right, there we go. Can you guys still read the trace itself? Can you guys read it? Okay, very good. All right. So we'll go ahead and get started with this particular algorithm. We start with line 11, which right off the bat is kind of confusing already because we have seldom seen anything like that. But so what you need to do is to think about line 11 just the way it is and say, okay, it's a combination of a conditional statement and an invocation of a subroutine. So you have to think, which one can I do now? Can I figure out which way to go? Should I go to line 12 or line 14? Or I can't even make that decision until I'm done with the invocation of the subroutine. Well, the answer is you have to do the invocation of the subroutine first. Okay, so that's exactly what we're going to do, is to invoke the subroutine to figure out, okay, once we're done with the subroutine, then we'll figure out whether line 11 still makes sense or not. Because there is a chance that it doesn't make any sense. If the subroutine returns a value like 5 or 10 or something like that, it doesn't make any sense. But if it returns true or false, then it makes sense. So we'll defer that decision until later, whether line 11 actually makes sense or not. So at this point, we are just kind of focused on, we'll go ahead and just invoke MR2 on line 11, and when it comes back onto line 11, then we'll decide what to do at that point. That means we need a return info, because in MR2, it is definitely returning a value in this case. So return info is going to say, when the subroutine is all done, we have to get back onto line 11. But when we do get back to line 11, it's still a conditional statement, except the condition of the conditional statement will be specified at that time. It will either be true or false, hopefully. But before we get back onto line 11, let's not worry about how we use the result of the subroutine. Then we have to set up the parameters, A, I, and also K. I is specified by the invoke statement to be 0, and K is specified to be 5. So those two are fairly easy because they are passed by value. A is passed by reference, but just like last time, it is also known as, in this case, column C to column F, because this time we have an array of 4 elements instead of 3. And we're done with setting up all the columns. There are no local variables, otherwise I would have to do the allocation here as well. And now we are done with setting up all the columns. It's time to get into the subroutine and start execution on line 5. Do we have any questions at this point? No questions? Okay. On line 5, it's a pretty easy condition to evaluate. All we want to do is to compare I to bar A bar and see if I is less than bar A bar. I is 0. Bar A bar in this case is bar B bar, because A is a reference to B, and there are 4 elements. 0 is less than 4 is definitely true, so we proceed to line 6 in this case. Line 6 is a recursive call. It has almost the same kind of element as the other one, except for one thing. Because in this case, it's a conditional statement. Well, it's a Boolean expression. Okay, it's returning true or false, and it has a disjunction. So we have to use short-circuit evaluation and evaluate from left to right.
So the question is would there be a comment as to if AI equals K? It would have to be true or false, and that would be in the comment section?
Nope. You just say return true right away, and and then it just pops your way back.
So you don't have to evaluate that expression.
In this case, you have to evaluate from left to right. You have no choice.
I mean, in the comment section. Is it required?
No.
Okay.
In the comment section, you don't have to say A bracket I equals K, because it will be clear when you modify the return info. It will be clear that you're actually returning true or false. So in this case, when we get to line 6, the first thing you have to do is to say, well, since I have to evaluate from left to right, I have to evaluate A bracket I equals K first. A bracket I is A bracket 0 because I is 0. A is an alias of B, so we are actually looking at B bracket 0, which has a value of 2. 2 equals 5 is false. So even with short-circuited evaluation, we cannot short-circuit in this case because the left-hand side of the disjunction is false, and we are forced to evaluate the right-hand side too, because that's my second chance to make the disjunction true. And that's why we have to actually go for the recursive call in this case. Now, in this particular case, it gets a little bit tricky because it's not quite the same as last time in a way. Because when we come back, we are still coming back to line 6, and the return is not done yet. That part is true. But you know what? At this point, we already know the left-hand side is false. So you have to say false in this case, and not just a bracket I equals k, because by this time, the left-hand side of the disjunction is already evaluated, and we know the value of the left-hand side already. Are we doing okay so far with this one? It's slightly different from the previous one. And then you have to say or, and then the other part is a question mark, because that really represents the invocation of the subroutine that we are trying to deal with at this point. The rest of this would be pretty much the same as what I have highlighted here, with the only exception that I is now one more than before, because if you look at how I invoke MR2, A specifies A, which means whatever was passed by reference to me, I'm just passing the reference along. K is K. So the only part that is changed is I plus 1 is now used to specify I. So that's why I is now 1 more than before. So if I paste this part here, I is the only column that gets changed, which is 1 more than how it was passed to me in the first invocation. And that becomes the context of the second invocation. Let me move the columns a little bit here so we can see a little better. There we go. So are we still doing okay so far? Scroll this one just a little bit more and scroll it back. Okay, now that I have set up all the columns for the next invocation of the subroutine MR2, I can now continue in execution in the subroutine that I'm invoking. And we always start from the beginning. Every time you invoke a subroutine, you start from the very beginning, on line 5 in this case. So line 5 still has to evaluate the same condition. I is less than bar A bar is true because 1 is less than 4 is true. Then we get to line 6, and we have to evaluate this carefully, because this time I has a value of 1, so we are actually comparing B bracket 1, which has a value of 6, to K, which has a value of 5. Once again, the result is false, so we have no choice but to invoke the subroutine because we have to evaluate the right-hand side of the conjunction. So we have to copy and paste this, and just put it here, and then change just I, so I becomes 2. The rest are still exactly the same as how it was presented to me. And then we continue execution on line 5 again because we're invoking MR2 again.
You put I as 23.
Oh, I thought I would remove the 3. There we go. Thank you. So on line 5, we evaluate the same condition, which is I is less than bar A bar. I is 2, bar A bar is 4, 2 is less than 4 is still true. We move on to line 6. But this time, we are looking at this expression, the disjunction, and we look at A bracket I first. A bracket I is B bracket I. I has a value of 2. B bracket I, which is column E, has a value of 5. 5 equals 5 is true. Okay. So since it is true already, I don't need to evaluate the right-hand side anymore. And as a result, I can say, okay, I'm returning true. I'm executing return true as a statement. Once again, how do I return a statement? How do I execute a return statement?
Copy the
2 things to do: copy and paste the return info cell, and change the question mark to the value that I'm returning. What value am I returning again? True. So it becomes just that. Yep.
Now, can we assume that somewhere within the array there is a value that would make it true?
Well, what if I cannot find anything that can make it true?
Well, you would end up at the end of the array, put back false, and then that would propagate outwards. Okay. I wasn't sure that.
Right, exactly. The last invocation of MR2 will get to line 8 because the condition is false in the conditional statement. And that false will propagate back, then you would end up with a whole bunch of return false or false, which evaluates the false, and then you update the previous one, and then you update the previous one. Right.
Yes. So on line 11, just kind of hypothetical, you're looking for if true, because if false, then
it prints R. Then it prints for line 14. It goes to line 14 and prints in RWD.
So it has to be if true in order to get to line 12.
Correct.
In this particular instance.
Right. Well, I did not want to say, line 12 is print value found, and on line 14 it prints, value not found, because I don't want to give anyone a hint of what the algorithm is supposed to do. So I just, give some random message, about MR2, which has nothing to do with the algorithm. I should have said,
It's
front wheel
ambiguous.
drive because it is false.
The ambiguity is on purpose.
Yes, absolutely. Question? No? Okay. All right. So I'm done with this one. Now this row here looks confusing because the return info cell is specifying, line 6, and yet I'm also executing line 6 right now. But you just have to separate, and say I'm executing line 6, it is returning true, and therefore I'm just modifying the return info cell to replace the question mark with a true. The fact that return info cell is on line 6 or it is a return statement doesn't matter at all. All you really care at this point is the question mark. Okay, where's the question mark? And replace that question mark with true, and I'm done. Are we still doing okay so far with this? Okay. So let's go ahead and after line 6, I'm getting out of the conditional statement. I will end up on line 10. Line 10 is the end of the subroutine. It's got two things to do. One is to tell me what I'm supposed to do after the end of this subroutine. I have to go back up to line 6. And then the second thing it has to do is to deallocate, in this case, 4 columns that I allocated for this invocation. So go back to font effect, specify strike through, and now I'm continuing execution on line 6. I'm back to columns K to N, but it doesn't really matter because it's not referring to any column in this case. It's returning false or true. What is false or true? It is true. Okay, so I'm actually returning true as a value true. So the only part of the columns that I really care about is the return info cell, because when I return a particular value, I copy and paste the return info cell, change the question mark to the value that I'm actually returning, and I'm done. So this looks exceptionally confusing because I'm on line 6. The very statement that I'm executing looks exactly the same as the statement that I'm updating that I'll execute later. But it is important to differentiate which one am I executing. Cell B15 is the statement that I'm executing. Cell J15 is the one that I will execute after I return from this invocation of MR2. Yep.
But when you're using Boolean operators as opposed to actual values, essentially the final answer that you get is going to always propagate backwards. Most in this, like this, if it's like this.
But the Boolean expression can be longer than just a disjunction. In other words, the disjunction can be in parentheses. Then I can have conjunction after that, or a whole bunch of other things, stuff after that. So whether this is a conclusion or not, is not up to me to decide. It's up to line 6 when I get back to line 6. Then that line 6 can decide whether this is done or not. All right. So the line 6 is now executed. I can proceed to the end of the subroutine, which is on line 10. So basically the same thing happens. I have to look up the return info cell to tell me what I'm supposed to do after the subroutine has ended. So once again, we go back to line 6. And then the second thing the end of a subroutine has to do is to deallocate the columns that we allocated for this particular invocation. So we changed all of these to strike through again to make sure that we are now deallocating column K to column N. And then we get back to the previous invocation. So we are now looking at column G to column J, continuing execution on line 6. Line 6 says return false or true. False or true evaluates to true. So we are just returning a value of true. Every time we return something, we copy and paste the return info cell, change the question mark to the value that we are returning. In this case, it is just a value of true. And we're done executing line 6. After line 6, we get to line 10 again. Kind of boring stuff because it's really the same thing. we look up the return info cell and say, okay, this is where we are going to return to, and that's the rest of line 11 that we have to deal with when we get there. And then we have to remember to deallocate the columns that we allocated for this invocation. And now we are back to line 11. But this time when we get back onto line 11, it is still the beginning of a conditional statement, but the condition is now specified. It is true. Okay, so technically speaking, in the comments column, we still have to say, the condition of the conditional statement, but this time it's pretty easy to specify because we can just say true is true. The first true refers to the condition of the conditional statement. The second true refers to the value of that expression. But this time it's just true is true, and therefore we go to line 12. Line 12 prints mid-engine. And then after line 12, we are done because that's the then branch of the conditional statement. There's nothing else after the conditional statement, and that's why we get to post, and we are done. Are there any questions about this particular trace? Go ahead.
What about the one on line 14 instead?
The one on line 14?
It doesn't matter, right?
Well, in this particular case of a trace, it does not matter. Now, if you want to do this as an exercise to prepare yourself for the exam, what you can do is change line 11. Instead of looking for 5 in the subroutine, pick something that is actually not in the array. Pick 7, okay? So change 5 to 7 on line 11, and you should get like 4 levels of invocation. No, I take it back. You should have 5 levels of invocation of MR2. The last one will return a false, and then you have return false or false, through all the way back. And then when you get back to line 11, it should go to line 14 because false is false, and you should print RWD instead. Okay, but that would be a good exercise to do. It's really just to modify the question a little bit to change the end result. If you don't want to go through all these iterations, you can make your array smaller. So instead of having 4 elements, just make it 2 elements. Okay, pick the first 2 element, truncate it, because it doesn't change the nature of the question. It just makes it a little shorter. Okay. Are there any questions about this particular question? I mean, the trace of MR2 in this case. No questions? Okay, all right. If there are no questions about this, I will save it into today's folder. And move on to the next question. Next question is MX5. And the United States is the only country that uses the Miata, the term Miata to refer to the same car. Everywhere else is known as the MX5 since the introduction of the car.
Well, technically, it's the Miata MX-5 in the States. So.
In the United States,
Yeah.
right? Because they couldn't. They tried to rename it to just MX5, and then people just could not associate, the MX5 to what we know as what we knew as the Miata. Yep.
Because it was supposed to be marketed toward women. You're pretending to market the car toward women.
I somehow, somewhat resent that remark.
I'm just saying. I know you've owned a Miata in the past.
I don't know, you can drop V8s in Miatas, so they can get pretty fun pretty quickly.
But mine has
originally the Miata in the United States, because Toyota had low sales for women between ages of 18 and 35, so they marketed toward women by calling it a Miata. It's a feminine name. In other countries, it's considered
as opposed to
sport.
Miato.
Yeah.
Well, actually, the term Miata, it depends on which source you get it from. According to some resources, the term Miata is actually has a German root, which stands for reward. So,
I know plenty of guys that have MX-5s.
and have no problems admitting to it.
No, he has plenty of problems.
I'll tell you one thing
would
though.
know.
I'll tell you one thing, which has to do with profiling, like police, cops, highway patrol. I thought that after I got my Miata, I would get like tons of, tickets, speeding tickets, right? Nope, I got nothing. Absolutely nothing. I got a speeding ticket when I had my Ford Escort. I'm not talking about the GT, I'm talking about the plain 3-door hatchback Ford Escort, and I got a speeding ticket at 65 miles per hour.
What was the speed limit?
The speed limit at the time was 55, but
Oh.
everybody was driving 65.
Everyone.
And I was singled out of all the cars on Highway 50 for driving at 65 miles per hour in the slow lane when every other car, on the other lanes were driving faster.
California.
Huh?
California.
Yeah. And my 3-door does not even have a spoiler. And here I thought, now I have a Miata, which doesn't even have a front license plate. Just for that, I should be getting tickets. No, it seems to be invisible, completely invisible to the highway patrol.
Mounting bracket?
Black. It's black. With a roll bar.
With the
No,
roll bar.
yeah.
With a roll bar, and if with modified exhaust, so the resonator is like modified. It's really loud, so it's screaming. Basically, look at me. No, highway patrol just kind of did not see it, and I was like, no, there's no car there.
Does it sound like this?
I think it's the profiling thing. It's like
If you try with the male version of the MX-5, the S2000, you get pulled over everywhere.
Oh really?
Oh yeah,
Male version.
everywhere.
Wow.
well, if you were commenting,
It was marketed toward females, yes.
Yeah.
Yeah, there are the
What about the
sportier
Z,
versions.
the BMW Z3 and the Z4?
Oh, everything.
Well, because that represents I got money too.
Pretty much. I can pay the ticket.
Yeah, I can afford it.
I can afford to drive 125 miles per hour. I'll stick with my Tesla.
The new one, Model S.
Porsche now, turbo.
Oh, not
He has like 7 or 8 speeding tickets. Like 7 and a half.
All right, so let's go ahead and get started with this one. Now, before we get started, we also just want to take a quick look at the algorithm and then try to figure out, what can it be trying to do here. All right, so it's once again it is a recursive algorithm, and
Deviation.
and it's just a different it's a variation of recursive algorithm. Okay, so this is the first statement. It invokes MX5, specifying this one has no array, so it has only 2 passed by value parameters. We have n and k. So then you look at the subroutine, actually inside the subroutine. The first thing we do is to check whether n is less than 10 or not. If n is less than 10, then we perform one of these two. But regardless of either one, it's the end of the recursion. It's either returning a 0 or a 1. Okay, it's not invoking MX5 again. Okay, so when n is less than 10, we stop the recursion. It basically does not call itself anymore. If n is greater than or equal to 10, in either case, we are invoking MX5 again. So the key is the link between invocations. In other words, you just take one or the other one, okay, and you just look at the invocation of MX5 again, and then you have to ask yourself, okay, how is this invocation, or how are the parameters related to the parameters that were passed to me, okay? And you can see that the only difference is instead of passing n to n, I'm passing n divided by 10, which is the floor of n divided by 10 to the next n. K is still k, that has not changed. And then there's a +1 at the end, which is not relevant until it is time to return. Okay. Yep, go ahead.
So only the value of n will change k1.
That is correct. K is really just being passed along the same way throughout all the invocations. So once you specify k is 1 on line 18, it's 1 all the way through. Okay, it's just specifying something that you have to use, and we are passing it by value. N is the one that gets changed. Okay, so if we start with 191, The next time will be the floor of 191 divided by 10, which is 19, and then it will be the floor of 19 divided by 10, or the floor of that, it becomes just 1, which is okay. So are there any questions at this point about this particular algorithm? Can anyone kind of guess what it is supposed to return?
Log 1.
0.
It should return 2, because there are 2 occurrences of 1 in 191. It's in a way a search algorithm, but it's actually counting how many times a particular digit is appearing in a decimal number.
In this case, it's trying to detect how many times 1.
Exactly. So K specifies which digit I'm looking for, and then N specifies the number that I'm looking, in which I'm looking for that particular digit. Okay. Well, give it a try and find out whether that's exactly what it does or not. I think I got the other window open already. Yep, I did. And we can also kind of shrink this column a little bit, and then change both of these to wrap around. That. And this time it automatically makes it bigger. Well,
I guess
not complain.
one mod 10 is one mod 10.
Yeah, N mod 10.
Right, and if n becomes 1, is 1 mod 10 1?
Well, when N becomes 1, it doesn't even get there because N is less than
Oh,
10.
yeah, that's true.
So it will go for, go to line 5 to line 9 in that case.
Yeah, I just don't see it.
Yeah.
All right, so let's go ahead and trace this algorithm. It doesn't even have everything set up because we don't have to have an initialized array in this case. So I'm gonna just start labeling the columns first. We have comments, line number, and there are no global variables. So the precondition has nothing to say. We start on line 18, and then we set up the columns. The subroutine MX5 does return a value, so we have to use return info in this case. And then we have 2 parameters, N and K. K is 1, and N is 191. The return info tells us what I have to do when I get back onto line 18. So I say, okay, we do have to get back onto line 18, and the print part is not done. The invocation of the subroutine will specify what I'm supposed to print. So that part is replaced by a single question mark. Now I have all the columns set up. I get to the first line of the subroutine, which is on line 4. Line 4 says, N is less than 10 is definitely false because it's 191. Then we get to line 11. Line 11 asks a second question, N mod 10 equals K. What do you think? Okay, first of all, what is mod again? The remainder of a division. So in this case, I'm dividing 191 by 10, but I only care about the remainder. That's 1, and 1 equals 1 is true. We say it's true, and then we proceed to line 12. Okay, line 12 is our recursive call, but I don't really need to know about this as a return statement or there's a +1 after that. I'm just saying, oh, okay, it has an invocation of a subroutine, so I have to deal with that first. So once again, we set it up for another invocation. When it comes back, we have to go back to line 12. And basically, we just copy the entire line except for the invocation itself. So in this case, it is return !+1, because that's the remaining part that we have to do when we come back onto line 12. N is passed as the floor of N divided by 10. 191 divided by 10 is 19, 19.1, but the floor of that is just 19. So N gets a new value of 19, or the new N has a value of 19. K is passed to K, so which is just 1. So now we have set up the columns for the next invocation. Continue execution on the line 14 again, line 4. N is less than 10, it's false because N has a value of 19. Then we get to line 11. N, in this case, is 19. Mod 10 has a remainder, or 19 divided by 10 has a remainder of 9. and equaling that to 1 is false. So we have to go to line 14. Line 14 is almost the same as line 12, except there's no +1 at the end. So what I'll do is I'm just going to copy and paste here, and then just change this part here and get rid of the +1. And also is changed because this time it is 19 divided by 10, which is 1.9, but we also have to take the floor of that, which is 1. So n is now modified to 1, and that becomes the new context for basically the last invocation of MX5. Continue execution onto line 4 again. N is less than 10 this time is true because n has a value of 1. Then we proceed onto line 5. Line 5 says n does not equal to k. That is false because n and k are the same in this case. So we have to move on to the else case, which is on line 8. Line 8 is return 1. Okay, so we now execute a return statement. When you execute a return statement, you copy and paste the return info cell, change the question mark to the value that we are returning, which in this case is 1. Then we get out of the inner conditional statement, and then we get out of the outer conditional statement, and we get to line 17. On line 17, we remind ourselves what we have to do after the subroutine has ended, and then we deallocate the columns that we allocated for this invocation. And now we can continue execution on line 12. But when we continue execution on line 12, we are now looking at column F, G, and H because I, J, and K are both, they're all deallocated. Now we execute return 1. When we execute return 1, we copy and paste return info cell, change the question mark to the value that we are returning, which is 1. And then that's it. That's all that line 12 has to do.
Shouldn't we be on line 14?
Oh, you're right. I forgot to update the line number. Thank you. Should be on line 14, and that's line 14 here. Okay, so we are on line 14, and line 14 is, when line 14 is done, it also has to continue execution at the same line, which is line 17. And it has two things to do. One is to remind ourselves where to continue execution, and the second to do the allocation of the columns. Now we are back onto line 12, but the context is now column C, D, and E. So when we execute return 1 + 1, which is return 2, we are going to update column C. Copy and paste column C, change the question mark to 2, not 1 + 1, because when you execute a return statement, you return a single value. You replace the question mark with a single value, but not the expression of the single value. The return statement is done. We get to the end of the subroutine, which is on line 17. We remind ourselves where we are supposed to go back to, and then we say these 3 columns are now useless. We deallocate the 3 columns. We continue execution at line 18, print a value of 2 to the screen, and then we get to the end of the entire thing. So it basically finds the number of digits that are the same as parameter k. So as an exercise, what you can do is to change parameter k from 1 to 9. Okay, then it should print the value of 1. If you change k to 0, it should print 0 because there are no digit 0 in 191. Okay. Are there any questions about this trace? No questions? Okay. Let me just make sure that I save this to today's folder first. And we are running out of time today, but we have one more session on Tuesday. So on Tuesday, I can go over more questions. Or when you study, you come across something and you have a question, we can definitely answer those too.
I like that. Study.
Study.
Huh? I was reading your shirt.
Oh, yeah.
The context of what you said. Sorry.